Do take note, for us to solve any question on R formula, there are two very important addition formula under your formula sheet, which is for sine and cosine, the addition formula. Please be familiar with it. We will go back to it in a short while. And in all questions, usually in part 1, it's a proving question. So take note. In this case, in part 1, you are told to show that the length of AB can be expressed in the form of P sine theta plus Q cosine theta. I do not know the value of P and Q. However, during exam, even if you do not know the value, just anyhow hum any numbers and solve accordingly for part 2, 3, and 4 to get your ECF. Alright, but in this case, I'm going to show you how to do proving. Take note, for us to do our proving, because we are using trigo, we must make sure we have right angle triangle. Alright, your first instinct is to form a right angle triangle doing this. Clearly, there are two right angle triangles, but this is not a good choice. Alright, two reasons. First thing, your angle theta is cut into half. Next, the triangle below over here, I do not have any length measurement, so it's not useful at all. I need to form right angle triangles where there are measurements. So this is a wrong choice. So what will be a better option? Take note, I must make sure the angle must be kept intact for theta. So usually drawing horizontal and vertical lines are important. So let me draw a vertical line down from point C. You can see that this is still a right angle triangle, and the good thing is the angle theta is kept intact. Okay, and there is a 5 meter for the line BC in that triangle. Not good enough. Why? I need another triangle for the one for 2 meter. So let me draw a horizontal line. And take note, in that small triangle that you can see up there, I must have an angle theta inside as well. Alright, so if I were to slowly transform, take note, this will be 90 minus theta. So in this case, this angle over here will be angle theta. So I'm able to make use of two right angle triangle to find the length of AB or BA. So I'm going to take a look at the triangle in yellow first, as BM is part of the length BA. So I'm going to make use of trigo ratio. Cosine theta is equal to BM over 5, which is the adjacent side over the hypotenuse. Then I'll express BM as 5 cosine theta. Next, I'm going to go to the small green triangle. You can clearly see that the base of ND is the same as MA, which is the part of the length AB. So in this case, I would like to express in terms of theta. Sine theta would be MD over 2 meter. So in this case, ND, which is the same as MA, this can be expressed as 2 sine theta. Now we can express our length in the form as stated in the question. Alright, and we have done our showing. Okay, if there are no numbers there, remember, during exam, you can hum any number inside. Alright, if there are numbers, of course, you are expected to do the next few parts by yourself. In part 2, you are supposed to express, alright, AB in the form of R sine theta plus alpha. Looking at the double angle, let us make use of this particular formula that you can see provided. Alright, and write the whole thing out before we do comparison. Okay, after I have written the double angle, and remember, you need to multiply the R inside. Alright, now I'm going to do comparison to see how we can do the next few steps. First up, alright, let us compare sine theta with a sine theta over here. Let us write the coefficient out. Alright, it seems that the coefficient of sine theta is equal to 2. Likewise, the coefficient of sine theta is also r cosine alpha. Next, look at the next one. Alright, I'm supposed to look for cosine theta, cosine theta. Likewise, please write the coefficient out. And this is where you secure your first method mark. After that is a routine. If you want to find your value of r, it's something like your Pythagoras theorem. Please try not to leave your answer in surd form. Okay, because there's a context, it's a measurement. Alright, give it to 3SF. Next, you will need to find alpha. In this case, make use of tangent alpha, which is sine over cosine. Do remember to check the question to see whether our angles are actually in terms of degree or radian. It's pretty obvious. Since the question has something in terms of 90 degree, let us please make sure our answer are in degree as well. And then rewrite your answer in the R formula stated in the question. And there you go, we have it for our part 2. Take note, if you want to find maximum or minimum value, what you need to do is to make use of the trigonometry. So in this case, they want AB to be a maximum. It means that my trigonometry, the maximum value for the trigonometry is actually equal to 1. If you refer to your sine and cosine curve, so let me solve of it equal to 1. And just have to do your normal solving. Remember to correct your answer to 1 dp for all answer in degree. Before we move on to our last part is to solve for it for AB to be equal to 3. So let me write the question out first. Remember, your AB was denoted by R formula in part 2. Since this is equated to 3, so now I just have to do my normal trigo solving. Alright, single trigo term. Alright, do your normal solving, find the reference angle, and remember, after finding the reference angle, I must take note there could be 2 possible answers in the first and second quadrant. It seems like in the first quadrant it's not possible because if I minus off the 68, I'll get a negative angle. So I'll find my solution in the second quadrant. And then I go about finding my theta for it, leaving our final answer in 1 dp again.